I think we already analyzed reaction A, B, and C, right? Pay attention, what are the substances you need to write into molecules? What are those you need to separate them into ions, right? Because this is a fundamental requirement for ionic equation, right? It really represents the ions reacting with each other in the solution. Do you guys have any further question regarding A, B, and C? Good. Okay, let's have a look at D. How to interpret this reaction? Let me give you an example, because later I'm going to ask each of you to answer the question. Barium oxide obviously is a acidic oxide or a basic oxide, guys. It's basic, right? So the basic oxides tends to react with water to produce the base. How to further interpret the reaction? You can try to understand in this way. It's still a double displacement. So Ba2 plus O2 minus H plus hydroxide. So they, exchange their partner. So this time, these two bind together. These two bind together. So this is why you need to have a 1:2 ratio. So you got water, you got barium hydroxide, right? So this is why you got a product like this. But if you write that into net ionic, we know barium hydroxide is a strong base. So you need to separate them. So this is why the final products are like this. Make sense to you? Okay, let's have a look at it.
I have a question.
Mm-hmm.
What's successive ionization equation?
Successful means step by step.
Oh. So how to? So what's the successive ionization equation for H2S?
For what?
Hydroxide, hydrogen sulfide.
The answer is already here. Colin, can you see my answer?
I mean, why this is the successive ionization?
So the same suggestion to you. You need to specify your question. So if you ask what is the successive ionization equation, it is here, right? So if you think this doesn't make sense to you, so specify your question. Which part doesn't make sense to you?
I think I'm not sure why it cannot be ionized by one step.
This is the APCAD. Diprotic or polyprotic acid always, dissociate step by step, and the successive step is much harder than the first one. How to interpret, the second step is harder than the first one, guys. If you compare the Ka1 and the Ka2, you will realize Ka1 is much greater than Ka2, right? So Colin, back to my suggestion. So if you didn't understand this, actually this is a very good question, but your original question, what is successive ionization equation, is not a good one, right? You know what I mean? You should ask, why it does not, dissociate in one step? Why it has to be in two steps? This is a good question. Any idea why the second step is much harder than the first step? Or how can we answer Colin's question? Why does the acid dissociate by one step, produce 2H plus?
because HS minus prefers to gain a proton, so it is harder for HS minus to lose a proton.
Mm-hmm. Kind of makes sense. We can make it, clear. You actually have different ways to interpret it. Losing one proton is easier. Losing the second one is harder. This is natural, right? Now say if I, take $10 from you, you probably feel, it's okay. Yeah, I have $100. But I need to get your second $10. You probably feel, wow, that's too much, right? You would say, no, you cannot do that. So it's pretty much the same for an acid. You can interpret the attraction between these two with these two, because the attraction here will shift the equilibrium to the left side, right? So which two have a stronger attraction considering their charge? Wayne, how do you think? Is the attraction between S2 minus and H plus stronger, or HS minus and H plus stronger?
I think it's between S2 minus with H is stronger.
Why?
Because K2 is smaller than K1.
But that is our conclusion we want to prove, right?
Maybe it's the structure.
Yeah,
I don't know. Actually,
just think about this is the 2 minus A9, this is the 1 minus A9, right? So if you just apply the Coulomb's law, the attraction in the second case should be much stronger than the first case, right?
Yes.
Any feedback from Colin that this makes sense to you?
Not very makes sense.
What do you mean?
I mean, so is that only because the two, just comparing the 2 minus and 1 minus, you can get the result that, okay, I see.
You can also compare the stability of the anion. Which anion do you think is more stable?
Probably 2 minus is more stable.
Why 2 minus is more stable?
Because I'm not very sure.
Mm-hmm. How do you think, guys? Which one is more stable? You don't need to argue from the octet because both sulfurs are octet, right? Jason, what's your idea? Which anion is more stable?
I think HS minus.
Why this one is unstable?
Because in HS minus there is a covalent bond.
Yeah, that is the difference. But how can we use the covalent bond to explain? Can we compare the stability in terms of the charge density? Right? This is a 2 minus on one atom. This is a 1 minus on one atom, right? So this is why the S2 minus is unstable compared to the HS minus.
But is this the biggest reason? Because I don't think, like, I think this is part of it. I feel like, because the Ka1 is so much greater, right?
Yeah.
So I feel like maybe there's another reason as well.
Oh, this one is already strong enough. Actually, you know,
Yes?
when we
Okay.
compare these two, the attraction, it gives you actually is a different perspective. It's the same idea pretty much. It's just from a different perspective. Let me give you another comparison. For example, if you have a diprotic acid like this, you also have the successive ionization, Ka1. Sorry. You have the second step, Ka2. So if you compare the delta Ka here, let's say this is called delta Ka, carbonic acid. If you compare this delta Ka with the delta Ka in H2S, you guys understand what is delta Ka, right? The delta is Ka1, let's say divided by Ka2, okay? It's not a subtraction, it's a ratio because, you know, these two values are so small. So which delta or which ratio do you think will be greater?
S. H2S.
H2S will be greater. Why you think in that way?
From my point of view, it's smaller. And it would be harder for it to hold into charge.
So if you compare, let's have a look. If you compare the structure of the first anion with the second anion, did you realize the difference? We said the 2- is more unstable than the 1-, right? Because the charge density. But this one is even worse. It's because both of these two charges are located on the same atom. But here, they are separated on 2 O-. Although in general, the overall charge is still 2-, but they are slightly separated. So if you check the data, this is around -7, this is around -11. So the ratio is about 10 to the power of 4. But if you check the data here, the first one is, I forgot, around 10 to -10. The second one is about 10 to -20. So the ratio is 10 to the power of 10. So the conclusion is correct, but we can interpret the stability of the anion with -2 charge from this way. Any further question, Colin?
Maybe not.
Okay, now I'm going to ask you guys to interpret reaction E. Anything to say about this reaction? You know, in terms of the type, the mechanism, the property of the reactants, the application of the reaction. So when we introduce a reaction, we do not just introduce, oh, this is the reaction, right? We want to, you know, further talk about the reaction from different perspectives, such as the type, right? The mechanism, the application, the, you know, special properties. What is the type of these reactants? It is the oxide, right? Can you classify this oxide? What type of oxide? Acidic, basic, amphoteric?
I think it's basic, right?
Right, this is the basic oxide. How about carbon dioxide?
It's like a little bit acid.
Yeah, it's acidic oxide, right?
Acidic, yeah.
Yeah, and then how you interpret the reaction, I will recommend you in this way. So the basic oxide can react with water to produce the base. But the acidic oxide can react with water to produce the acid. And then the acid and base will neutralize to produce the salts. And it will also produce water. So this is why the water is cancelled. So this is just a way for you to interpret the reaction. It doesn't mean you must have water to make the reaction, because basic oxide can react with acidic oxide directly. You can also use the Lewis acid base theory to interpret the reaction, because it is a transfer of a O2 minus between calcium oxide with carbon dioxide. So when this one loses the O2 minus, it then changes into calcium 2 plus. When the CO2 gain the O2 minus, it changes into the carbonate. So this is also a Lewis acid base reaction. So this is something we can further extend the reaction. Make sense? And last time we also talked about the Lime cycle, right? This is the opposite process. One of the reaction in the Lime cycle is, in the Lime cycle, when we get a limestone from the ores, we heat it. We want to decompose the calcium carbonate to produce the calcium oxide, which is called the unslaked lime, right? Yang, what is the meaning of slaked again? I remember you answered the question last time.
Can't remember. I don't think I answered this. Did I answer this?
Yeah, I think you answered this question. You checked the meaning for us.
I don't think I ever Googled it. It doesn't show up in my search history.
Slake or slaked means, I think it's kind of, adding water, basically. So if you add water to calcium oxide, it will change into calcium hydroxide. So this is called slaked lime, right? Because it weighs water. So now I have a question. This is the combination or synthesis reaction. This is the decomposition reaction. So under what kind of circumstances the second reaction is spontaneous? Because we cannot make both of these two reactions spontaneous at the same condition, right? That makes sense.
High temperature.
Why it needs high temperature? Why the heating is useful here? What is the driving force of the reaction?
Because the change of entropy increase.
There is a gas produced, right? So according to delta G equals to delta H minus T delta S, this is a reaction with a positive delta S with the gas production. And also the delta H is also positive because this is a endothermic reaction. So increase the temperature will help the delta G to decrease and finally to be negative, which means it will be spontaneous, right? And this process, the delta H is negative because it's exothermic, and the delta S is also negative because the gas is gone. So this is why you need to put into relative low temperature or room temperature to make this reaction spontaneous to the forward direction. Now this makes sense to you? So there will be a transition element, there will be a transition temperature, which means if the temperature is higher than this value, the reaction will be this. If it's lower than this one, it will be the first one, right? I mean the spontaneous direction. So what is the transition temperature? How to express the transition temperature by using the parameters here?
Delta H over delta S.
Right? Because when delta G is 0, which means these two reactions are at equilibrium states, right? So if the temperature is higher or lower, you can change the direction. Now, since you know both of these two are positive, so you definitely will get a positive results, right? So if you have the data, you put the data in, the temperature is around 1000 Kelvin. So about 700 degrees Celsius. So with this kind of temperature, the calcium carbonate can be decomposed. So do you think it's really interesting for us to analyze a reaction like this? You can analyze from different perspectives, right? And I hope with this kind of analysis, you can have a better understanding. Any question? Great. How about this reaction? Andrew, would you mind to give an analysis? Briefly talk about your understanding about the reaction here. N2O5 oxide, right? What type of oxide?
Acidic.
It's acidic, right? It's acidic. So it reacts with water to produce an acid. Make sense?
Yes.
So why is this acid not the other acid? Why is not a nitrous acid? You may analyze the oxidation number of this nitrogen here. It is +5. And here is still +5, right?
Yes.
Nitrous acid is plus.
We're setting at
It's HNO2.
Yeah.
So the nitrogen here is +3, right? So this is why it shouldn't be nitrous acid, because reacting with water in a non-redox way should give you the same oxidation number, right?
Yeah.
So how to further interpret the reaction? Personally, I prefer you analyze by using the double displacement reaction pattern. So in the N2O5, you have the N5 plus, you have the O2 minus. You also react with the water and exchange the partner. So you got water and you got NOH5. If we draw this stuff, you got something like this. This is unstable because the nitrogen cannot have 5 bonds. But what can it do? It can lose water. When you lose water, this is gone, and then you make a double bond. So you got this. This is quite similar to the phosphoric acid, because the phosphoric acid is exactly in this way. But it still does not, solve the problem of the, octet. It still has 5 bonds. So it keep losing water. But this time, it does not make a double bond. Because, limited by the octet rule. It has to carry the positive charge. But finally, you got the nitric acid, which is HNO3, right? So this is the way how I interpret this. I never find this kind of stuff from any textbook, but it's just my personal understanding. It might not be correct, but I think it can be a way for you to interpret the reaction. Okay, we have less than 10 minutes, I think. We can continue to talk about a few. So let me try to add one more question to you. First, Jason, could you please give a name to this oxide?
Phosphoric pentaoxide.
Can you say that again?
Diphosphoric pentaoxide.
Okay, very close. Phosphorus, right? Okay, you don't need to say phosphoric. It's just the cation. The cation use the name of the element. My second question is, what would be the products? You can let me know the formula first, and then we figure out what is the name.
Should be H3PO4.
H3PO4. So what is the name?
Phosphoric acid.
Do you guys agree with Jason? If we replace the nitrogen into phosphorus, and it stop here, right? The reason why phosphoric acid can stop here is because phosphoric acid can disobey the limitation of the octet rule, right? It can have more than 4 bonds, 8 valence electrons. Very good, right? One more. How about if we have P2O3 reacting with water? What would be the product? This is an open question to any of you. Considering the pattern you learn from here, go ahead, William.
I think it is still H3PO4.
Oh, interesting. So which means there is an oxidation?
Oh, H3PO3.
H3PO3. So what should be a good name for the H3PO3?
Phosphorus acid.
Yeah, phosphorus, right? The ic turned into OUS, right? That means a relative lower oxidation number. One more question. There are a bunch of stuff we can talk. So if we know the phosphorus acid is a diprotic acid, can you draw the Lewis structure of this acid? Yeah, you guys can annotate on my screen. I think we should have enough space. It's a diprotic acid. It's not a triprotic. You may need to interpret this first. Why it is not a triprotic? Since there are 3 hydrogens, right? Any idea, guys? Don't just watch the screen. Try to draw it either on your paper or on my screen, right? You need to try, otherwise you cannot figure it out. But I think before you start to draw, you need to figure out why is diprotic? Why there is one hydrogen different from the other two? It means these three hydrogens have different connections, right? So two of them are connected to which element?
Oxygen.
Yeah, the last one is connected to
phosphorus.
Yeah, phosphorus
Really?
is not so electronegative, right? So the pH bond is not polar enough to make it acidic. Makes sense, right, Yang Jie?
I'm very surprised.
You didn't take the AP Chem yet. So in the, I think Unit 5, we are going to talk about the acid strength. So one factor to determine the acid strength is the polarity of the bond. If the bond is more polar, the acid is stronger. So it totally makes sense. Okay, now it's your turn, guys. Come on, draw the structure. You already know the pattern, right? So you just need to put the bond there. Yeah, Jason, I will recommend you put the OH here into HO. You want to show the oxygen is connected to the phosphorus, although it's not a big issue. Okay, all of you got the same results, right? Very good. One more question. So we have an acid which is called hyperphosphorus acid, which is H3PO2. And it is the monoprotic acid. Can you figure out the Lewis structure? You can clear your drawing and then draw a new one by yourself. Oh, Yang Jie, so fast. Do you agree? Two hydrogens are connected to the central phosphorus. Only one hydrogen is connected to the oxygen, right? Make sense?
Dr. Chen.
Yeah.
Why POH3 for phosphorus acid is not correct?
Can you say it again? Which one is not correct?
POH3. So the phosphorus connected to 3OH.
Oh, that means it's a triprotic acid, right?
Why is not a triprotic?
Oh, you are asking, the question is like this. Your question is about why this one is more stable or more correct than this structure, right? Am I right? First, the fact is, the phosphorus acid is a diprotic. So this is why we said this structure is more reasonable. But if you're asking why it's not this one, the way I would like to answer is phosphorus still want to make 5 bonds, because more bonds probably will make the structure more stable. But this is something I'm not very sure. It can be a perspective for you to think. Because we do have stuff like this, right? We also have stuff like this. So if you have enough chlorine gas, the PCl3 will combine with Cl2 to produce the PCl5. So thermodynamically, I will say the PCl5 is more stable than the PCl3. So probably the comparison here between this one and this one is similar. But this is a good question, H3PO3. Okay. I think it's almost
Hold on, I
time.
have a question.
Mm-hmm.
I have a question.
Mm-hmm.
So why the hydrogen is losing from oxygen?
We already answered this question, right? Did I talk about this?
I think I forgot.
I forgot. Okay.
Yeah.
Think about the electronactivity difference. You can check the electronactivity of hydrogen, phosphorus, and oxygen, and then you will figure it out. Leave this as your homework, okay, Colin?
Oh, yeah.
Okay.
Yes.
So we leave the last question on this page, but this one is pretty straightforward. It's just a oxidation, right? It's a combustion. So if you combust a substance, you only need to convert all of the elements into the most stable oxide, right? So that this makes sense to you. Carbon is carbon dioxide. Sulfur is sulfur dioxide. We can continue to discuss why SO2 is more stable than SO3 tomorrow, okay?
Oh, Dr. Chen, I think oxygen is more negative, so that like the difference is larger, so it's preferred to being broken.
Yeah, you see, you even didn't check. You got the answers by yourself, right?
So why it's preferred to broke if the difference is larger?
What? Think about the dissociation need to produce H plus, Colin.
Yeah, I mean, like if you disconnect hydrogen from the phosphorus, you can also get a H plus.
How?
When
The
why not?
the bond is not polar, Colin.
I think it is polar because there's
What?
like difference in electronactivity. So the
The
bond should be
difference is
polar.
not big enough, right?
Oh. So.
Leave the question
I
for you
see.
to think
Okay.
after class, okay,
Yeah.
Colin?